Hello everyone, today I'll talk about lasers. So this is the laser light with different colors. Okay, so laser is light amplification by stimulated emission of radiation, and Einstein was the first man who gave the concept of stimulated emission in 1917. Then first maser was introduced by Charlestown, working in Columbia University in 1954, because a maser is the microwave amplification by stimulated emission of radiation. So it has a wavelength of about 1 centimeter. So then first a working laser in visible range was discovered by Theodore in Hughes research lab in 1960. Then why are the lasers are important? First is its line width. The line width actually describes the purity of laser. So narrower the line width, more probability that it consists of a single frequency monochromatic light, so single wavelength monochromatic light. So in contrast with this incandescent bulb which emit the white light, and which have a wide spectrum, because white light is a superposition of all the colors. So line width is important because single wavelength or single energy is very important by doing a different experiment. So the second important property is its coherence. So for example, this is the laser light. So coherence is when the waves are in phase, when troughs meets the troughs and crust meets the troughs. So the light will be in phase. So if it's if they are in phase, it's they are coherent, and if they are with a single color or single wavelength, single frequency, they are monochromatic. So laser light is monochromatic and coherent. Then this is the example of LED light, which is monochromatic, one color, but not in phase. It's not coherent. So uh, it's yes, it's monochromatic, but it's not in phase, and monochromatic and non-coherent. Then sunlight's not monochromatic and non coherent. So what are the different properties of typical laser? It's stimulated absorption, spontaneous emission, and stimulated emission. So first we will describe the stimulated absorption. Stimulated absorption is simply is the rays of electron from lower energy state, ground state, to the excited state. So by, for example, by electromagnetic radiation, which is a quanta of energy is equal to the difference of energy between these two states. So h mu is equal to energy difference between 1 and 2. So this will stimulate the electron to go to the high energy state. So this is called as the stimulated or induced absorption. So of course the electron will not stay in the excited states forever, and it will watt down by emitting a photon of the same energy, h mu is equal to 1 2. So this will known as the spontaneous emission, and it's very very obvious. So this is the schematic diagram of the spontaneous emission when electron from this excited state come to the ground state by emitting a photon of energy h mu 1 2. So if you want to find the rate of spontaneous emission, so the rate of decay of electron from here n1 is the number of electrons in the ground state, and n2 is the number of electron in the excited state. So the rate of absorption is the decay of electron in the ground state is equal to the number of electron. Of course, in the ground state, more number of electron in the ground state, more they will absorb and get to the excited state, of course. And also they will depend on the density of incoming photon of energy h mu. So when we equate these two equations, we will get this equation, and by and with the proportionality constant b12, which is the proportionality of absorption, is also known as coefficient, Einstein coefficient b12. It's absorption coefficient and Einstein coefficient. So for the rate of spontaneous emission when electron emitted from excited state come from excited state from ground state and emit a photon. So of course it depends on the number of electron in the excited state. So dn2, the rate of decay is directly proportional to the number of electron in the excited state, and the proportionality for the rate of spontaneous emission is a to 1. So this is 2 state and this is state 1. Einstein was the one who proposed that there is another process other than spontaneous emission, which force the electron or which stimulate the electron in the from excited state to come to the ground state by emitting a photon of the energy difference between the energy of these two levels. So he was the one who proposed that under certain condition it is possible to force an excited atom emit a photon by another photon, another photon. So hence we will get an enhanced beam of coherent light, which is a property of laser. Because for example we have a photon, incoming photon like this, and which stimulate the electron in the excited states, and so electron come from excited state to ground state by emitting a photon. So output will be we will get 2 photons. So of course we will get an enhanced beam of coherent light by just 1 photon. So from 1 photon we will get 2 photon, or from 2 photon we can get 4 photons. So we will get enhanced beam of coherent light. So this is the property of laser. So Einstein was the one who proposed that there is another process other than the spontaneous emission, and which is known as the stimulated emission. So so the decay rate of the stimulated emission is directly proportional to the population of electron in the excited state, and also the incoming density of photon with energy h mu. So by equating these two equations, we will get this equation by having a proportionality constant b12, which is the Einstein coefficient of stimulated emission. So by the principle of detailed balance, we will have total rate of absorption is equal to rate of emission, and Einstein was the first who proposed that the rate of absorption is equal to the rate of spontaneous emission and the spontaneous emission. So by solving this equation and dividing b12 and 1 to both sides, we will get this equation, and then by using the Boltzmann equation for attaining the final equilibrium, and 2 divided by n1 is equal to E minus del E divided by KT, we will get this equation for the density of photon of energy h mu. So this is the final equation which was proposed by the Einstein, and then this equation was proposed by Planck while working on the black body radiation, which explained the radiation up to ultraviolet region, up to ultraviolet region. So these two equations can can equate under certain conditions, in which A21 divided by B21 is equal to this side here. So it means that the laser action can only be achieved if B21, which is stimulated emission, are much higher than A21 spontaneous emission. Of course, if we can get more stimulated emission, then we'll get more enhanced or coherent beam of light. It means that if we have more number of electrons, or more population of electrons in population of electron in excited state is greater than in the ground state, then we will have we can achieve the laser properties or laser action. So this process is known as population inversion, in which more number of electron in excited state and then the lower energy state. And this concept is fundamental importance for the production of working of laser. So if we can achieve N2, for example, if we have a two energy state and we can achieve N2 is greater than N1, then we can achieve the population inversion, in which number of electrons in excited state more than in the ground state. So the question is that can we achieve the population inversion in two energy state? Can we achieve or not? So by looking at the Einstein or solving the Einstein equation, and we can say that, or we propose that it is not possible to have the population inversion, or by looking the simple phenomena, we can say that it's very impossible to have the population inversion in just two energy level. So the three level system was introduced by using the semiconducting materials, in which the electron from the ground state pumped to the excited state, and from this energy level E2, it will non-radioactively decay to the this level E3. So this E3 level is a metastable state because its lifetime is greater than E2. It's about 10⁻⁻12 seconds. So T3 tau 3 is greater than tau 2. So in metastable state, the electron will spontaneously go to the ground state by emitting a photon, and then this photon will stimulate the other photon for the stimulated emission and come to the ground state. So within a very short span of time, the metastable state will be empty. So the three level system will give a pulse of laser in this way. We will have a high amplitude, and then there is a decay of laser, and then we will have amplitude, and we will have a decay of laser. So the pulse of laser will be achieved from the three level system. And of course the population inversion is very hard to achieve in a three level system, because every time we need to pump the electron to go to the energy level E2 and then to E3. So this the population inversion, which is between the N3 and N1, because we need N3 is for the laser to be action, we need N3 is greater than N1. So it's very hard to achieve in the three level system, because we need very high every time we need a input of energy. So these are the disadvantages of the three level system. So was the pulse of laser, there is no continuous laser, and then the more energy is the input, more energy is was required to achieve the population inversion. So the four level system was introduced, in which the electron was pumped to ground state to E2 state. From E2 state, the electron will non-radioactively decay to the metastable state, and then the by first spontaneous emission will occur, and then it will come to the E4 state, and then of course in a very short span of time this electron will non-radioactively decay to the E1 state. So the population inversion will be done between the E3 and E4. So it is very obvious, or it is very clear, that the number of or the population of electron in E3 will always be the greater than E4, because this is a metastable state. Electron will stay higher in this state, and then but E4 will also in a very short span of time the electron in the energy level E4 will come to the ground state. So it's more probability that N4 or population of electron in N4 is almost zero, and also here it's also zero, because it will non-radioactively within no span of time, it will non-radioactively come to the N3, and here it will come to the E1. So the population inversion will, it's very easy to achieve the population inversion in 4-level system. So it means that a 4-level system is more efficient than a 3-level system. So, and we will get a with less energy we'll get a continuous pulse of um, and coherent um, high energy light, laser light, with the by using the 4-level system. So this is all for now, and thank you for listening and watching the video. Bye bye.